Good morning. This is Professor Asif Iqbal Mullah. So, in the last session, we were discussing about assembly level language based development. So, several factors we discussed under the topic assembly level language based development. So, here you can see you have many advantage if you use assembly level language to design a firmware to develop our embedded system. So in that many advantages are there. You can easily understand this if you read the things here. The advantages are efficient code memory and data memory usage. The data memory and code memory you can easily you can efficiently use, because if you want to write the assembly level language program, you must know about the target processor architecture, its memory organization, about its internal blocks. You should know each and everything while you are writing the assembly level language program. So if you know the internal architecture of the controller, a processor which you are using in embedded system, so you can easily reduce the usage of memory here, whether it is a code memory or a data memory. Then high performance, the performance is very high if you use assembly level language, because optimized code not only improves the code memory usage but also improves the total system performance. Then you have a low level hardware access. The hardware access the low level hardware access is the next advantage we have when you use assembly level language. So because of the most of the code for the low level programming, like accessing the external devices, specific registers from the operating system, kernel, device driver, low level interrupt routine, etc. So therefore definitely the hardware access here, it is a low, because you know the architecture, how you have to utilize it. Then we have a code reverse engineering. The one more advantage, that see, reverse engineering is the process of understanding the technology behind the product by extracting the information from the finished product. So therefore here you can using reverse engineering, you can understand the product. So like that we have several advantage we have when you use assembly level language. And you also have some drawbacks when you use assembly level language, that is high development time required for the assembly level language is definitely very high, because assembly level language is much harder to program than the high level language. It is not easy, and the complexity is more when you write the program using assembly level languages, because the developer must pay attention to more details and must be through knowledge of the architecture. That is one more thing, is that the developer must know about its architecture, its memory, its register details, everything, and its inner detail. So using that, if you writing the program takes more time, and it will be little complexity. Then we have a developer dependency. There is no common written rule for the developing assembly language based on the application, where high level language instruct certain set of rules of the application development, because it is developer dependency in the sense what. So all which you written in the assembly level language is for particular that microcontroller or a processor which you use in the embedded system. You cannot use that language or that assembly code for some other microcontroller designed by some other company. So such as 8051 microcontroller, whatever the language you written for 8051 microcontroller in assembly, whatever the program you written in assembly for the 8051, you same assembly language program you cannot utilize it for the 8086 or some other controller, ARM controller and some other controller, because so each and every one have its own separate assembly level language and set of rules that you cannot utilize. Whereas in the high level language it is not that. You can utilize it. You can set certain set of rules. You can be share with a different development, with a different controller here, such as the program written in C, right? So next we have a non-portable. It is not portable because the target application written in the assembly level language are valid only for particular family processor C and cannot be reused for another target processor or controller. That is there, that what I told. If the target processor controller changes, the complete rewriting the application using assembly instruction for the new target processor is required. That is what the thing is there, right? So next we'll go for the high level language based development, and this is all nothing is there. You easily you can understand this if you read here. So high level language, here you see, as we seen earlier section, assembly level language based program is highly time consumable, tedious, require skilled programmer with a sound knowledge of the target processor architecture. Also the application developed in the assembly level language are not portable. Here comes with the here comes with a role of a high level language. Any high level language with supported cross compiler converting the application developed in the high level language to a target processor specific assembly code. We will see that is there in the high level language with see high level language with supported across a compiler which converts the high level language into the assembly level language. We will discuss a cross compiler in details. So that is there. The most of the commonly used high level language for the embedded firm application developed in the C. Sorry, usually it is developed in C. Some of the also developed in C++. The various types of involved in the high level language based embedded firmware developing in a is the same as the assembly level language based development, except the conversion of the source file written in the high level language to the object file is done by using a cross compiler. See, so here to convert the high level language into the machine level language, so that is the machine code, so which is we are sending to the target processor, so that the target processor the processor controller can understand its machine code. So to convert this here we are using a cross compiler. It is the same as what you seen in the assembly level language. In the assembly level language we are using assembler here, but in a for the high level language we are using a cross compiler. That is what the source file which is so usually here, so in many embedded system the program is written in the form of modules, right? It is modular programming, means several programs we are returning here and taking it as a one module, right? You can see the various steps involved in the conversion of the program. So here so here you can see what you can see here, the translation of high level source code to executable object code is done by cross compiler. There are cross compiler for the different high level language for the same target processor are different. See here, so the cross compiler which we are using is different for different high level languages. It is not the same. For C it is the same, it is a different. For C++ it is a different. Such as we have a C51 cross compiler for Keel software is an example for the cross compiler, right? C51 is a popular cross compiler available for the C languages for the 8051 family of the microcontroller. Conversion of the each module, see here, so several modules we are using here to write the program. See, one big program we can divide into several small programs, and that those programs we called here modules. Or in other words we can say we can write the program not in we are writing the program not like we are full one program here for full one task, means full for one embedded product. The program written is not only one, so it is a set of programs. Which set of programs we called a modules, means the whole whole task or whole the target is to be achieved by using several programs here, which programs we called as modules, right? So modules, so each module you can write in different high level languages. You can it is allowed to write in different high level language, but it should be compiled with its own compiler, with its own cross compiler, right? It is not like that. It means, say one module is written in C, another module can be written in C++, but the cross compiler utilizing for C is a different, for C++ is different, and for, say, one more module is written in Java, the cross compiler for that is we are using for the cross compiler for the Java, we are using its own cross compiler, not the cross compiler of C, right? Once it is compiled, it will become an object file, right? So this object file is not having absolute address location. So to locate absolute address location, we use a locator, and locator we also called a linkers, because sometimes it will link, we require some files, library files, which is to be linked to our object file to become it is executable file. So we call this absolute object file. When this absolute object file is need to be converted into hex file, that is hex file is a machine code file, right? So so you can see here how this high level language is to be converted. See here, several advantages are there in high level languages. You read this: reduce development time. We can reduce the development time here. So you discuss this in assembly level language also, how it is increase the development time. Here you can reduce the development time because the high level language is a simple English language. You can easily write, and it is it is not it is a simpler language, and which is user friendly for the programmer. So programmer can easily understand this. There is no complexity, and the programmer does not require to know the detail of the processor or a controller, means detail of the architecture, about its memory, about its register. So only it should have a certain knowledge of certain register is enough to write the program. Means development independency, because one language, one syntax, one program which you written in one language, you can utilize it for the another target processor. So only the certain set of rules you need to be changed, and so the adjustment, the ports and register which you utilize there, you need to change. It is a portability, easily you can portable. Means target application written in high level, same thing, are converted into a target processor or controller, understandable by the cross compiler. Okay, same thing it is. So limitation for the high level language based, it is that the merits offered by high level language based design takes advantage over its limitation, right? Some cross compiler available for the high level language may not be sufficient in generating the optimized target processor, right? See here, yeah, that is there. And the target image created by such compiler may be messy or non-optimized in the term of a performance. Well said, because see, some compiler which is convert the high level language into its machine codes, that machine code may be a lengthy if you same machine code if you written by hand, right? So that causes that requires more memory as compared to when you written same program by written hand, which is require less memory. So that is one disadvantage we have here, right? And the investment required for the high level language based development tools is very high as compared to assembly level language. That's another drawbacks. So in the next session we'll discuss next topic, which is mixed assembly and high level language. So till then, take care, be safe, stay in home, bye bye.